Hello guys, we'll be solving the problem schedule meetings. Let's take a look at the problem statement. Imagine you're organizing a series of meetings for a group of people, each with its own schedule time. The problem is that some meetings overlap with each other, which can cause scheduling conflicts. The task is to figure out how many can be removed entirely so that no overlapping meetings are there. For example, if one meeting starts before another finishes, they overlap. However, if they just touch at a single point, like one meeting ending exactly when another begins, they are considered non-overlapping. Here given a list of these meeting intervals, and you need to find the minimum number of meetings to cancel so that all the remaining meetings can be scheduled without conflicts. So in this question, we need to find the minimum number of meetings which can be cancelled so that the remaining can be scheduled without any conflict. And we can see that if two meetings touch at a single point, like one ending exactly and another begins, they are non-overlapping, which means that they are allowed. Input format. The first input line contains integer t, which is the number of the test cases. For each test case, the first line contains an integer n, which is the number of the meetings. The following n lines contain two space-separated integers representing the start and the end time of the meetings. N, which is the number of the meetings, can only range from 1 to 10 raised to 5. The start time should always be less than equal to the end time, and the start and the end time can range from 1 to 10 raised to 5. The output format. For each test case, we have to output a single integer denoting the minimum number of meetings that can be removed to make the rest non-overlapping. For the sample input, 2 is the number of the test cases, 4 is the number of the meetings for the first test case. Here 1 is the start time, 2 is the end time. Similarly, 4 inputs are given for the test case 1. For the test case 2, 2 is the number of the meetings. Here again, 1 is the start time, 2 is the end time. Similarly, two inputs are given. Now let me explain you the test cases. For the test case 1, the following input is given. We can see that here 1 to 3 is overlapping 1 to 2 and 2 to 3. So either we can remove 1 to 2 and 2 to 3, or we can remove 1 to 3. But since we need to find the minimum number of meetings that have to be cancelled, so we will have to remove 1 to 3. Instead of removing 1 to 2 and 2 to 3. So if we remove 1 to 3, the output will become 1. And if we remove 1 to 2 and 2 to 3 while keeping 1 to 3, the output will become 2, which is wrong. So to prevent this, we have to sort it on the basis of an end time. The meetings list have to be sorted on the basis of the end time. The reason is that if the meeting ends earlier, then we will have more room for the subsequent meetings. But if a meeting ends later, then we can only place less number of meetings after it. So that's why we have to sort it on the basis of an end time. Here, 1 to 3 meeting is removed, so the output becomes 1. For the test case 2, the input is 1 to 2 and 2 to 3. We can see that there is no overlapping and they just touch at 2, which is allowed. So the output becomes 0. Now let's take a look at the code. The code will be in Java. We have a class solution, the main method. We have a scanner object sc, which will help us in taking the input. We have an integer t defined, which will be the number of the test cases. We have a while loop, which will run till the test cases is greater than 0. Here integer n is declared, which will be the number of the meetings. We will have an array list named meetings, which will contain integer arrays. Then we will have a for loop from 0 till n minus 1, where the start is taken as input and the end time is also taken as input. Then it is stored in the meetings array list in the form of an integer array containing two elements, where the element at the 0th index will always be start and the element at the first index will be the end time. Now, since we have seen that we have to sort the elements on the basis of an end time, because if a meeting ends earlier, there is more room for the rest of the meetings. So we will use the sort method. Then we will have a comparator class where we will be comparing the integer values. Then we have a lambda function here where array A is taken as input and the array the first element of the array is given as output, then the first element, which is the end time, will be used for comparing, and that on that basis the list will be sorted. So on the basis of the end time, using the comparator class, we will sort it, and then we have declared the last end, which will contain the meetings list dot get zero, which means that the array at the zeroth position in the meetings array list. Then in that array, the first element at the first index, which is the end time. Then we have declared the remove count and assigned it zero value. Then we have a for loop ranging from 1 to n minus 1. Now, if meetings.getI, which is the array in the array list at that particular index. And then we have to see the start time of that particular array, which should be less than the last end time. So we are comparing the start time of the array with the last end time of the previous array. If the start time is less, then we will remove it and we will increment the remove count. Else, we will update the value of last end to the current meetings end time, which is meetings.getI and the first element at the first index, which is the end time. We will update it and assign the last end that value. Now we will print the remove count and we will close the scanner. Now let's run the code. It has passed all the sample test cases. Now we will submit it. It has been accepted.